everyone, my name is Christian. Next, we have a talk by one of our supported sponsors, Google Open Source, that for sure we have many new features and tools and everything that we could try. So I hope you enjoy. Let's welcome our sponsor.
Thanks for joining me today as we talk about LLMs and Gen AI and how it's not magic. It's just code and APIs. My name is Anna Eilering. I'm a developer relations engineer at Google, where I work in the Open Source Programs Office, also known as OSPO. I have a background in applied machine learning, and I've worked on a variety of infrastructure and framework projects at Google over the years. Initially, I was here to talk to you about how LLMs and Gen AI aren't magic, how it's just code, y'all. But, well, since I got you here, instead, I need to talk to you about the future. I'm not here to talk about Python. I'm here to talk about the future. I'm here to introduce the Global Verb Exchange, GVX. We solve the biggest problem in AI, connectivity. This is the world's first hyperscale verb liquidity protocol. It decentralizes all of your actions via the verb interchange. The world is fragmented. Data is siloed. You have servers and clients speaking different languages. It's a mess. It's legacy. We can disrupt this. We can disrupt this old paradigm to better synergize with the global marketplace of ideas. Our agents negotiate with the remote intelligence. If the agent is happy, it returns a 200 OK sentiment. If it's confused, it gracefully handles the 404 hallucination. This is the future of communication. To do this, we had to invent a new protocol called the Universal Resource Locator. Using this Universal Resource Location string, we can directly interface with remote AIs in order to synergize effectively. With a single line of prompt engineering, which in our system is called a GET, we can get data from anywhere. We can put data, we can even post and delete it. We have broken the boundaries of time and space, and we have allowed AIs to talk to each other. We've got trillions of parameters for your action prediction. We can do generative AI interfaces. We've tokenized your verb assets. We have high frequency request optimizations. It's okay. I can't anymore. I gotta stop. I gotta take a breath. If it wasn't apparent, if you hadn't caught the joke yet, I'm just hyping up the Python requests library. But admit it, for a second, this sounded like every AI pitch you've heard this year. And I get why marketing does it. I get why the business folks do it. It's fun, but it's exhausting. And it makes us, the engineers, the technical folk, feel like we're falling behind if we aren't prompt whisperers, if we aren't effectively disrupting the status quo with our synergistic energies. But here's the deal. It's just software. It's just APIs like everything else we do. As Pythonistas, as Python enthusiasts and Python professionals, we're in a fantastic position because we know how to use APIs. We know how to share code. We know how to handle this. How many of you in this room know exactly how a BGP routing table works? Do you know how they update across the Atlantic? I do not. I would have to admit that I'm not sure I remember what a BGP table is. How about implementing TCP and UDP, like in the chart here, from scratch? I could not. I mean, with enough time and research, sure, but I use the internet every day. I use requests.get all the time. I use it directly, and I use it in other libraries. The request API abstracts the complexity of the physics of the internet in a way that allows me to use it without having to implement it. And somebody in the audience right now is like, I could implement this, no problem. And to you, I say, that's cool as heck. But there's still a lot of hard stuff that we use all the time because we can share our expertise, and we don't need to be the one to build it from scratch. That's the power of Python, right? NumPy, Pandas, Vertex AI, Matplotlib, SciPy. There's countless libraries that we use. And, with time, with effort, we could absolutely implement those things from scratch and understand them. I believe everybody in this room could. But we don't need to. We're stronger together because we can share this power. We can share this code. This is the power of Python. This is the power of open source. We can use libraries and APIs from other people and do cool and amazing and useful things with them. LLMs are the same. You don't need to understand the physics, the attention mechanism, the weights, the neural layers, the forward feed and the hidden layers in order to build cool and useful things. That's the power of our community. That's the power of Python. We can use powerful libraries that other folks have written, and this isn't a new thing. This is just how software development works. We stand on the shoulders of giants and we support each other. A major problem is that we treat AI like a chaotic black box. We hardcode prompts, we hardcode our endpoints, we spaghetti it through the code, auth here, prompt there, and we hope for the best. But that's not engineering. That's gambling. That's hype. A lot of times our focus isn't on the problem we're solving, but the tool. And I think that's a little bit bananas, isn't it? I would never hire a hammer-first carpenter to build me a house. To build a house, you need to use way more tools than just a hammer. Thankfully, as good technical folks, we have a whole toolbox of tools we can use. So how do we fix it? How do we approach this? Well, we use Computer Science 101, abstraction. We create an interface. This isn't an AI technique over here. This is just software design fundamentals. By doing this, my application doesn't care if it's talking to Gemini, GPT-4, Claude, a potato. It doesn't matter because it's through an interface. Why do we do this? Well, for starters, I refuse to pay 5 cents every time I run PyTest. And I refuse to deal with flaky, non-deterministic tests. When we treat our code like this, suddenly that non-deterministic LLM endpoint is just like any other non-deterministic endpoint or tool or API. It's fully testable. You can interchange it easily, and it's adjustable. Side note, if you take away one thing from this whole talk, mock your LLMs. Your CI/CD pipeline will thank you. Your code will be better. Your product will be better. Your wallet will thank you. Now, because we used an ABC, swapping the model is a configuration change. You want to move from one provider to another? Change one line in your config. You want to go from cloud to local? You want to do A/B testing for different RAG implementations? All of these are just config pushes now. It's not a code rewrite. This is the power of using computer science fundamentals that we already know how to do when we're talking about these very powerful APIs. Then there's RAG. People treat RAG like rocket science, and it looks and sounds intimidating and scary. I mean, look at the acronym there, Retrieval Augmented Generation. It sounds intimidating, but it's not rocket science. When we treat these things like APIs and code, it's just plumbing. It's just another API call. A user asks a question, you query your database, whether it's SQL, vector, an agent, whatever. You shove that data into an F string and you send that new F string into the LLM's API. If you can write a SQL query and a Python F string, you're a generative AI engineer. This is why we should think about these things through the lens of all the other code we work on daily. This is what we should be building towards. It's not magic. It's computer science fundamentals. It's infrastructure. It's code. Notice how boring this code looks? That's the point. It looks like requests. It looks like Seaborn. It looks like NumPy. That's the goal. Boring is good. Boring means reliable. Boring means you can ship it. Your ideas, your product is the exciting part, not the tool. The most important variable in the AI stack isn't the model context window. It's not the parameter count. It's not the model you choose. It's you. Don't let the hype scare you away. It's just an API. It's just Python. Grab a key, write a test, and build the future. Thank you so much for listening to me today. My name is Anna Eilering. I'm from Google OSPO. Let's go build.
Did you like the session? I am certain that you did. So once again, remember that Google Open Source is one of our supported sponsors, and I'm certain that you can have some questions both for the company, but also for Anna's talk. And maybe she will be more than happy to continue the discussion in the Google Open Source channel. So maybe drop by and continue the talk with her. So enjoy the conference.